right, let's have a look at this question. Is the graph of the equation a circle? If not, explain why. If yes, state the coordinates of the center and length of the radius. Then sketch the graph of the circle in a 2D Cartesian plane, clearly labeling the coordinates of the x and y intercepts, if any. Okay, so first of all, to check if this is a circle, we need to check if we can convert this equation to a form like this, right? X minus h squared plus y minus k squared equals r squared, right? Okay, so this is our target. Okay, first of all, note here we have x squared plus 4x, right? 4x can be rewritten as 2 times x times 2, right? So this is the number you're looking for. We can try x plus 2 squared, right? And on a scratch paper, if you expand it, you will get x squared plus 4x plus 4. And as you can see here, you have x squared plus 4 in the original equation, but there's no 4, so we need to subtract it, right? And now let's consider the y's. So note here you have negative 6y here. So negative 6y is 2 times a y times a negative 3, right? So we can try using x minus 3 squared. And again, if you expand it on a scratch paper, you will get x squared minus 6y plus 9, right? And there is y squared minus 6y there, but there is no 9, so we need to subtract it. So therefore, this expression is exactly the same with the left side of the original equation, right? And let's copy the right side here. Okay, let's call this original equation asterisk. So basically the asterisk is equivalent to the new equation here. All right, then we move all the constants to the right side, which is equivalent to x plus 2 squared plus y minus 3 squared equals 16, right? All right, of course, this has already in the form of a standard circle, right? So you can make the conclusion. It is a circle. And the coordinates of the center is, so note here, x plus 2 is actually x minus 2. So x coordinates of center is -2. The y coordinates of the center is 3, right? And the radius is a square root, positive square root of this number here, which is apparently 4, right? Okay, so if you want to sketch the circle, you need some more information. For example, the x and y coordinate, y intercepts, because this question asks us to label these points there, right? Find its x intercepts. You can let y be 0. Then find the value of x's. This means x plus 2 squared plus 9 equals 16, which is equivalent to x plus 2 squared equals 7. Therefore, x plus 2 must be positive or negative square root of 7, right? Therefore, we have found the values of x's, 1 by 0. X is -2, positive or negative square root of 7. Therefore, the x-intercepts are -2 plus square root of 7, 0. And the other one is -2, negative square root of 7, 0. All right. Then let's find its y-intercept. That means let x be 0, then find the values of y, right? Which means 4 plus y minus 3 squared equals 16. which gives us y minus 3 squared equals 12, right? Which means y minus 3 should be positive or negative square root of 12, which is 2 times square root of 3. And this gives us y is actually 3, then positive or negative 2 times square root of 3. Therefore, the y-intercepts are 0, 3 plus square root of 3. The other point is 0, 3, negative 2 times square root of 3, right? Okay, now we have all the key information here. Center, radius, x-intercepts, y-intercepts. Then we can sketch the graph. X-axis and y-axis. First of all, the center. Center is -2, 3, which is about here, right? -2, 3. And radius is 4. So roughly it will have a shape like this. And these are the x-intercepts, and these are the y-intercepts. Let's label them on the graph. X-intercepts -2 plus 7 square root of 7, 0, and -2. Oh, sorry, this this should be negative here. The other one is -2 plus square root of 7, 0, which is apparently greater than 0. And of course, it should be to the right of the y-axis, right? And the two y-intercepts are 0, 3 plus 2 times square root of 3. The other one is 0, 3, -2 times square root of 3. And of course, the length of R is 4, right? Okay, so please have a look at this question and let me know you're ready to proceed to the next one.
Okay.
All right, next question. Consider the equation 3x squared minus 6x plus 3y squared plus ky equals -6, where k is some real constant. That means real number, and it's a constant, right? Where what values of k is a graph of this equation? A circle, B, a point, C, not existing. Okay, to determine if this equation is a circle, a point, or something else, we need to convert it. We need to check if we can convert it to a form of x minus h squared plus y minus k squared equals some r squared, right? Or equal to some other constants d. And then to determine and to check the value of d, whether it's greater than 0, equal to 0, or less than 0, right? If it is greater than 0, this is a circle. If it is 0, this is simply a point, right? Which is a degraded circle to a point. If it's less than 0, apparently no such x pairs can fulfill this equation. Therefore, the graph of that equation does not exist. Okay, so let's check if we can do this. Okay, so first of all, note here the leading coefficient is not 1, right? In order to simplify this equation, first of all, we can divide both sides using a straight, right? So let's label this with asterisk. The original equation is then equivalent to x squared minus 2x, then plus y squared plus k over 2y, right? Equals -3, which is equivalent. Note that this is our target, right? So we need to convert the x terms including x to some squared binomial, right? So note here, the -2x can be rewritten as 2 times x times -1. So we can try using x minus 1 squared, right? And if you expand it on a scratch paper, you will get x squared minus 2x plus 1. And as you can see here, the first two terms are exactly with the same with the first two terms here. But there is no 1, so we need to subtract it. Therefore, this part is exactly the same with this part here, right? And then let's consider the y. So note here, the k over 2y can be rewritten as 2 times a y times 4 over a k over 4, right? So this is the number you're looking for. Then we can try using y plus k over 4 squared, right? And again, if you expand it on a scratch paper, you will get y squared plus 2ab, which is 2 times y times k over 4, right? Plus k squared over 16, right? And this is y squared plus k over 2 times a y, then plus k squared over 16. And as you can see here, first two terms are exactly with two terms here, but there is no k squared minus over 16, so we need to subtract it. Can you follow me? And
Yes.
this way, excuse me.
No, I was just saying yes.
Okay, so in this way, the expression here is actually exactly the same with the left side, right? Which means we have successfully transformed the left side to some squared binomial. And then we can copy the rest, which is -3. Okay, and all the work here can be done on a scratch paper, so I just erase this. All right, so this is further equivalent to, you can then move all the constants to the other side, right? -1 is a constant. Because k is constant, so -k squared over 16 is also a constant. So let's move all the constants to the right side. Then we have we have x minus 1 squared, then plus y plus k over 4 squared equals -3 plus 1 plus k over 16, right? Which can be simplified. The right side can be simplified to k squared over 16 minus 2, right? You understand? And
Yes.
here, this looks more like a circle, right? And whether it is a circle or not depends on the right side. So we need to discuss the value of the right side. First of all, a circle. When it's a circle, this value needs to be greater than 0. It is a circle, right? Or we can say 1 k squared over 16 minus 2 is greater than 0. It is a circle. Why? Because only 1 is greater than 0. This can be treated as the squared r, right? This r can exist. So that means when the right side is greater than 0, it is a circle. Which means k squared over 16 must be greater than Excuse me, let me check. I made a mistake, sorry. This should be -2, right? Not -3. Can you spot it? There is a typo there. Because when we divide a 3 to both sides, -6/3 should be -2, right? Sorry for this. This is also -2, -2, and this should be -1. Can you follow me? Okay, so when k² / 16 - 1 is greater than 0, it is a circle. That means k²/16 needs to be greater than 1. That means k² needs to be greater than 16, right? So can you solve this inequality? If k² is 16, what is k? Can you think of that?
It's 4. Less than 4.
Okay, let me check. Sorry about this. There is another typo. This should not be 2, right? This should be 3. And this should be 6. Okay, let's let's redo this. I bet. Okay, first of all, we can divide both sides using a 3, right? Which means the asterisk is equivalent to x² minus 2x plus y² plus k/3y, right? Not k/2, but k/3y. And equals -2, right? And then first two terms, consider the first two terms. We have x - 1 squared, then -1, right? And note here the k/3y can be considered as 2 times y times k/6, right? This is the other number, so we can try y plus k/6 here. And then we need to subtract k²/36, which equals -2, right? And this is equivalent to x - 1 squared plus y plus k/6 squared equals -2 plus 1 plus k²/36, 36, which is k²/36 -1, right? And then the left side already looks like a circle, and then we need to discuss the value of the right side. So first case, if the right side k²/36 - 1 is greater than 0, it is a circle, right? Which means k²/36 needs to be greater than 1, which means k² needs to be greater than 36. And then can you solve this inequality now? What is our k here? If k² is greater than 36,
Then k is greater than 6.
so this means k is either greater than 6 or less than -6, right? Is it correct?
Yes.
Okay, so that means when k is greater than 6 or k is less than -6, it is a circle, right? And second, if k squared over 36 minus 1 equals 0, that means the right side is 0, right? If the right side is 0, apparently this is a point, right? It is a point, which means k squared over 36 equals 1. Then k squared is 36, which means k is either positive 6 or k is negative 6, right? And can you see which point it is? Can you tell me which point, the coordinates of the point?
It's 0, -6 or 6.
Okay, you need to discuss, right? When k is 6, then k over 6 is 1, right? The equation is x minus 1 squared plus y plus 1 squared is 0. So what is that point? At, can you tell the coordinate of the point?
-1, 1.
1, -1, right?
Yeah.
Because as you can see here, this is a number that is non-negative. This is also a non-negative number. If the right side is 0, this number must be 0. So x must be 1, right? And this number is also 0. So y must be -1. So of course, this point is 1, -1. Can you follow me?
Yes.
Okay. So there is another case, right? When k is -6, then the equation is x minus 1 squared plus y minus 1 squared equals 0. And this is a point at, can you tell me the coordinates of the point? Can you tell the coordinates of the point?
Negative, I mean 1, 1.
1, 1, right? Yes. And see, if the right side, which is k squared over 36 minus 1, is less than 0, there is no graph, right? Because there is no solution. So there is no graph. Why? Because as you can see here, this number is non-negative, and this number is also non-negative. If the sum of two non-negative numbers equals a negative number, that can't happen, right? If that can't happen, that means there's no solution. If there is no solution, that means there's no graph. Can you follow me?
Yes.
Okay, I'll give you some time to have a look at this question. And then let's proceed. Tell me when you finish, okay? Then we can proceed to the next one.
Okay.
Okay, let's see the next one. So this time you are given 3 points that are on the circle, and try to find the equation of such a circle, right? Okay, if you know 3 points on the circle, the best way to express the circle is to use the general form equation, right? Okay, suppose, okay, we can say suppose the equation of such a circle is x squared plus bx plus y squared plus cy equals d. That's the key point number 4, I think, right? Because when it's a circle, it can be expressed in this general form, right? And then we know that these 3 points are on the circle. That means we can plug these 3 points onto that equation, right? Okay, first of all, if we plug -2, -6, we have 4, -2b plus 36, -6c equals d, right? And then we also have when x is 6, that means 36 plus 6b, then y is 0. So that means this equals d, right? And then we have 5, 1. When x is 5, that means 25 plus 5b plus 1, y is 1. So that means 1 plus c is d, right? So let's label them as 1, 2, and 3. Sorry. First of all, it's better to simplify the equation, right? So let's simplify them first. First equation can be simplified to 40 minus 2b minus 60 equals d. Second one, 36 plus 6b equals d. Next one, 26 plus 5b plus c is d, right? Then let's label them as 1, 2, and 3. Okay, so we need to solve this system of 3 equations. Okay, first of all, we can eliminate one of the variables among b, c, and d, right? We can put equation 2 into 1 because equation 2 says d is just 36 plus 6b. So if we put equation 2 into equation 1, we'll get 40 minus 2b minus 60 equals 36 plus 6b, which gives us 8b plus 60 is 4, which means 4b plus 3c is 2, right? And then we can put equation number 2. We haven't used 3 yet, right? So we can put it in 3, which get us 26 plus 5b plus c equals 36 plus 6b, which means b minus c equals 10, right? Okay, so in order to eliminate c, we can convert it to 3b minus 3c equals -30, right? Let's label them as 4 and 5. Then we can use number 4 plus number 5. This will give us left side is 7b, right side is -28, which means e is -4. So we have successfully solved or B, right? Okay, so when B is -4, we can put it to equation number 4, right? So that means 4 times -4 plus 3c is 2. This means 3c equals 2 plus 16, which means c is 6, right? And we have successfully solved the c. And we also know that we can then put b equals -4, c equals 6 into second equation. Seems easier, right? That means, oh, sorry. If we put it into the second equation, we don't need the value of c. We can just put negative b equals -4 to second equation. This means 36 plus 6 times -4 equals d, which means d equals 12, right? Okay, so that means we have successfully solved all b, c, and d. All the three coefficients are determined, therefore the equation of such a circle is x squared plus bx, means -4x, and plus y squared plus cy plus 6y equals d, which is 12, right? Well, that's the final solution. All right, so please have a look at this question and let me know if you finish, okay?
I finished.
All right, then let's have a look at the last one. Okay, you are given two equations, means two curves, two graphs, right? Do the graphs of the equation 1 and 2 intersect? If so, at what points do the two graphs meet? So to determine if the two graphs intersect or not, we can just put the two equations together and try to solve this system of two equations, right? If there is any solution, that means the two curves intersect there. Okay. So we can start from the simpler one, which is a linear equation. We can just put the linear equation into the second equation, right? Which will give us x squared plus y squared, okay, not y. So y squared is simply x minus 5 squared, then minus 4x, then plus 12y, y is x minus 5, plus 27 equals 0, right? And then we need to simplify this equation, which means x squared plus, expand everything, x squared minus 10x plus 25 minus 4x plus 12x minus 60 plus 27 equals 0, right? Then combine all the similar terms. 2x squared means 2x squared, and minus 10x minus 4x plus 12x gives us minus 2x, right? Then plus 25, negative 60 plus 27 gives us negative 8, right? Equals 0. Then we can divide both sides using 2, which means x squared minus x minus 4 equals 0. This is apparently not difficult to solve, right? This is simply a quadratic equation. We can use the quadratic formula to solve it. So first of all, let's check the determinant delta. Delta is defined as b squared minus 4ac, right? Which is b is -1 squared minus 4 by a is 1 by c is -4. then this is 1 plus 16, which is 17, right? And you should expect the square root of 17 something in the next step. So x is given by the quadratic formula, which is 2a is the denominator, which is 2 by 1, which is 2. And then negative b, which is 1, right? Then positive or negative square root of delta, which is square root of 17. So these are the possible solutions of the intersection point. Also, we need to find the y coordinate of the intersection point, right? So we need to discuss if x is 1 positive square root of 17 over 2, then what is our y, right? So note here, y is always x minus 5. So on x minus 5, you will get 1 plus square root of 17 over 2 minus 5. This is actually 2 is still the denominator, and negative 9 plus square root of 17, right? And if x is 1 minus square root of 17 over 2, then y is x minus 5, which is, let's put x in, then minus 5, which is 2 is still the denominator, and this is negative 9, negative square root of 17, right? Therefore, we can make the conclusion. The two graphs intersect intersect at the following points. Okay, first of all, x is 1 plus square root of 17 over 2, and y is negative 9 plus square root of 17 over 2. The other point is 1 negative square root of 17 over 2, and negative 9 minus square root of 17 over 2. Okay, and this should be the final solution. Okay, so any questions?
No.
Okay, then I'll put my notes onto Google Classroom, okay? And I found that you have committed many mistakes on the squared binomial. So I'll give you some more practice for you to practice, such as something like this, okay? And write to some squared binomials, okay? I'll give you some practice for you at the very beginning of the next assignment, okay? And it's not on the Google Classroom yet. I'll let you know when it's available, okay? Can you hear me?
Yeah. Thank you.
Okay, then I'll put the notes first on Google Classroom. And if you have no questions, you're free to go. Have a nice week.
All right. Thank you. You too.